Okay, so thank you for showing up this late in the day. It's the ArcGIS API for JavaScript Building Mobile Web Apps session. My name is Lloyd Heberlie. I'm a product engineer on the JavaScript API team, and I work on the website that is basically our public-facing SDK. So basically the whole build process that puts that website together, I manage that code base. And then I also work with Andy and work on these mobile presentations for Developer Summit and User Conference, and help do some of the mobile testing, and then samples and blog articles and just kind of a bunch of stuff across the board. But the majority of my time is spent on managing the ArcGIS API for JavaScript website that's on the developer site. And Andy?
And I'm on the developer outreach team. My focus is working with customers worldwide on web mobile as well as native Android. So this is right up my alley on the kind of cool stuff that I like to work with.
Awesome. So the agenda for today, we're just going to kind of cover some basic expectations, talk about designing for mobile, talk about debugging, which is a very important skill that you'll learn if you get very far with doing application development for mobile browsers. And then Andy will talk some about frameworks and some things about geolocation. So the understanding is that you're here because you're web developers. You want to leverage HTML, CSS, and JavaScript to target many devices and viewpoints: desktop, tablet, phone, and then potentially different types of device vendors as well. So we'll quickly just jump out of the slide deck, and I'll show you where some of these things that we're going to talk about today are in the SDK. So this is the 4.3 that we just released last week. Under the Guide tab, you'll see working with the API. There's widget development, the view UI. There was an earlier session today where they talked about some like creating and working with responsive widgets that Kelly Hutchins and Juan Carlos Franco did. I'd recommend that you watch that one as well. But the view UI has some supporting abilities to control where things get positioned on the screen, and then also be intelligent, where if you are changing the viewports, that you can have padding and different types of things that can really be helpful in mobile design. So there's some additional samples down here that talk about view padding, and so this will be a resource that you'll want to look at. In addition to that, the styling topic talks about the different CSS and the theming, and so if you want to change the colors to match your branding for your company, you can do that. All of the SAS is available, and we'll talk a little bit later about frameworks, and if you use some of these frameworks, they actually provide SAS, which is a CSS language that you can run through a preprocessor, and it spits out the compiled CSS. So this it will also be good information for you. And then under the sample code, a lot of what we're going to talk about today is the pop-ups, and then also under the widgets, all of the different things that you might put into your application and how those interact with being on a mobile device. So that's where, after this session, if you want to come back and put the stuff together that we talked about, that's where you'll find all that content. So we'll transition now into talking about designing for mobile. And the first thing that I have is a demo that I'll show you about the touch experience on mobile devices. So this is a screen recording, and after doing this session for like, I don't know, 4 or more years with Andy, with the Wi-Fi and you know, the devices and being plugged in, and it just doesn't work really well with reflecting what you're actually seeing. So this is actually, I think, is much more meaningful for you to see it this way. Basically, I used an app called Reflector to have my devices and my laptop be on the same Wi-Fi network, and then you can just cast your screen to the device and see that on the screen, and that's what we're going to be seeing today in these different recorded demos that I have. So using the touch assist ability in iOS, you can record gestures, and so here we're showing the zoom in with the 2-finger pinch that you would show to zoom in and then zoom out. And on Android devices, they have dev tools that will actually show the screen coordinates and the navigation. In addition to that, we're showing the swiping here, so that, you know, just touching the screen, dragging your finger across it. So all of these events and navigation are supported. And then finally here we'll do a rotation, like 2-finger rotation. So you just put your fingers on the map and twist it, and that will rotate the map for you. So all of these things are just built in. There's nothing that you have to buy into to get those to work. They're just enabled by default. And that was the compass widget that you saw there at the very end that's underneath the zoom controls. After you've rotated the map, you can just touch the compass widget and it'll reset the map back to true north. So one of the things that you can do with designing for mobile is use these HTML5 input types. So when you have a form or some kind of input control, you can say type equals email, and that will bring up the keyboard, the textual keyboard with the @ symbol on it. You can say type equals TEL, telephone, that'll bring up the number keyboard. Type equals date will bring up the date spinner, and you're seeing that on iOS and Android there. And the purpose of this is to give your users a better user experience for data entry. So, you know, make it as easy as possible for them to get the information in there and try and alleviate ways that they can make mistakes whenever inputting information. This is a look at the base map gallery across, so the screen left to right is iPad, iPhone, and then Android. So they just kind of work as far as showing up and displaying on mobile. And then the styling information that I showed you, you can take that SAS and do what you want to it to change the color and other attributes with all these widgets, because we do provide the view models and the SAS for these different widgets. There's also the base map toggle, and the difference between the base map widget and the base map toggle is that the toggle just lets you toggle back and forth between 2 different base maps. So that's the you know, like the topo and the aerial. And then this is the home button. It's really hard to see up in the left-hand corner, but the home button actually provides, you know, whenever you navigate out of area from wherever the initial extent was, you can touch the home button and it takes you back to the initial extent. This is the out-of-the-box layer list, and so it's just, you know, provides some ability to toggle off and on visibility of layers and sublayers. and then also the layer list action widget that provides capability for being able to perform a custom action on any of the layers that are in your layer list. And you saw the compass in that screen recording, but basically it allows you to be able to see how the map is rotated, and then also with touching that or clicking the compass, it will reset the map back to its normal navigation mode. And there's cool things that you can do with mobile, like hooking into, and Andy might talk a little bit about this, but hooking into some of the device controls and then controlling the rotation of that whenever you move the map to have the map rotate. And so you could potentially hook up the compass to do something like that as well. The locate button does what you think it would. You touch it and then it asks if it can have access to your location, and whenever you do that, then it uses the HTML5 Geolocation API to zoom you to your current location. And so we'll take a look at that in a short screen recording that I have here. So after you touch that, normally it'll say, do you have access to your location? I think I had done it once before whenever I was recording this. And then it'll just zoom you to wherever your current location is. And then, I just zoomed out here so you could actually see it wasn't zoomed in so far. And it just, it just uses your device's location in order to be able to pull that information in. One of the great things about the 4 version of the API is that kind of everything, all the widgets have been re-architected and redesigned from the get-go. So over the years of experience that we've had with 3, we've had the pain points of customers and lessons that we've learned. And so everything has been designed with responsive first, so it'll work in tablet and different desktop and phone viewports. So by default, the pop-ups have an auto setting as far as where they'll show up in like the top right corner or the bottom on a mobile device, but you can also change what that default is depending on the configuration need for your application. And we'll take a look at that later here in some of the other samples. We have a project or a sample that I'll show you in a little bit that's in the SDK. It's called Calcite Maps, and Calcite is just sort of a code word or a name that we've used for some of the theming and styling that we've used at Esri. And this is a project that is built on top of Bootstrap, which is a CSS framework, and Andy will talk a little bit about those. And it can potentially be a good starting point for you because they've already done some of the heavy lifting for setting up where these different components will lay out by default. And if you're already familiar with Bootstrap, then it will, it'll fit right in. But as you can tell on the tablet, we've got the settings panel there, and then on the phone, at smaller viewports, it shows up at the bottom by default. And that's just kind of some of the things that you expect from a responsive framework, is that things fall into place where they should be to make it easier for the end user to get to the content that they need. So there's a light theme as well. Here we're looking at the base maps in the Calcite Maps project. And then here we're looking at what the user experience is whenever they click on that and they get the drop down or they get that option list on Android. So these are the kind of things that you want to have for your users, so it is easy for them to navigate through the content of what you're trying to show and display for them. So if we look at the pop-ups, all right, let's just open that in a new window. You'll see that by default, whenever this gets down to a smaller screen, that pop-up just falls into the bottom part. And you can change, where that would be and what the default is. So like if in this condition, it shows up in the top. And so this is all, there's nothing that you have to do in order to get this to work. It just works this way now. And so that's pretty awesome. Let's see here. The responsive widgets, this is an example where whenever we move the screen to a small viewport, that those things hide. So that's this is a sample that you could potentially use, leverage the code in to hide or remove things from the user interface. So I would, suggest or recommend that you take a look at those different widgets, and then we also have a link to this calcite maps in Bootstrap down here that you can check out and play with and see how those things work. So in the case like we're talking about the base maps, you see it's up there. And then whenever you switch down, it drops down into the bottom. So this is a project that someone at Esri, Al Laframboise, maintains, and so there's already all the work that's been put together to get our stuff to work with Bootstrap. So if you use Bootstrap, I would recommend that this is somewhere you potentially look at to start, and it could potentially jumpstart your development time. So let's move on to productivity and code management. So you're going to have to get your dev machine set up, which is, you're going to need a web server. You're probably going to use source control like GitHub or something to keep track of version changes in your code. You'll want to, do code quality and verification, and then you'll probably pick an IDE. And you may even, install Node, and we'll talk a little bit more about why you might do that. So there's different IDEs and different tools that can control the spacing, and if you use tabs and how many lines it indents, and it'll check your code to see if it's valid or not. That's a great thing to do. Keeps your code clean. Clean code is good, especially if you work in a team environment. Node is basically like a headless engine of running JavaScript. There's a lot of tools out there to do task automation like Gulp or Grunt, and then other tooling that can combine and pack up your JavaScript files or copy files or do the CSS pre-processing to convert the SAS into the compiled CSS. So it's likely that you're going to have all of this tooling set up for your development. We'll talk in a little bit about what acetate is. So there's different tools out there and projects like ESLint, JSHint that can check your code to see if it has the proper indentation or ends in a semicolon or has the brackets where it needs to. All of these things just save you time if you accidentally make a coding error and won't break in your browser. A lot of the newer code bases and CSS frameworks are written in some sort of language that runs through a CSS preprocessor like Sass, and it spits out CSS. So that's a technology that you're probably going to need to get familiar with if you're not aware of it. And I have a demo to show you with some of the stuff, the work that I do and use for building the website for the JavaScript API. So what you're seeing here is that I'm changing the title in the page, and as soon as I hit save, the whole thing's going to rebuild, and you'll see in all of the screens that it changed to Hello Dev Summit. So what's happening right now is that there's this acetate program working. You could see how whenever I expanded that side nav, that you saw that on the other devices as well. This is a great way that you can test for multiple screens all at the same time in your desktop view and on your devices, and sort of jumpstart the testing that you're going to need to do in order to make sure that this content works on all the devices. So you'll also notice things like in the desktop view, there's tabs across the top, and then there's an option drop-down list on the mobile devices, and see how the spinner comes up on iOS and how you have the select option list there on Android. Those are things that just make for a great user experience for folks on mobile whenever they're trying to navigate through your page content. But like as I had mentioned, this uses Acetate, which is a static site generator. It's a tool that Patrick Arlt built, who works on the ArcGIS for Developers team. And basically it allows us to build all these pages together to create this website. One of the things you'll see now is that how whenever we look at the API reference on the mobile devices and we scroll down into the page, you'll see that there are hyperlinks that show up whenever you're on the mobile device. And the reason why this is of concern is that on desktop devices you have touch click experience. You can mouse over things and have things show up. Well, on mobile devices there is no on mouse over experience because you're using your finger to do the touch and the navigation. So we should see here in a little bit when we scroll down that you'll see a hyperlink show up on the mobile device. And whenever I click on the screen, you'll see that it's right there next to it. And that's all done using media queries to recognize when you're on a mobile device to do something specific for that mobile device to change the layout. So that's a really cool thing that you can do with these different media queries. And the last thing we're going to look at here is how you get a different layout on mobile devices in the sample code as well. So you'll see that the navigation turns into drop-down lists on the mobile devices, and the side nav is hidden, and that way that page content is viewed first, so they're not the navigation isn't in the way of them actually getting to read the content first and see the map. So this is kind of the whole deal, or whole purpose of doing like responsive design, is that the content is king, or what's the most important part of showing to the user across any device and for the web application that they're experiencing, that you will build. So here what we're looking at is that instance or that example where on those mobile devices that link would show up. So whenever the page loads, we inject a data attribute element on the HTML class, and we basically inject the user agent into that. And then on the right-hand side, what you're seeing is the CSS selector that is then changing the default display property of that hyperlink, which its display is by default set to none. Whenever it figures out that it's on a mobile device and that mobile is in that attribute selector, then change the display property to inline block, so it'll actually show up. And it's a pretty cool, neat trick to be able to do that. I don't remember, I found it online somewhere, but it's a way for you to use media queries to show content different on a mobile device than you would in the desktop view. And then one other thing I wanted to briefly mention is that you can also do media queries in JavaScript as well using the match media. And this allows you to dynamically create and respond to the change in the screen width on the different devices, and then execute some JavaScript based upon what screen width they're at. So it's a pretty powerful thing. This is the other session that Franco and Kelly Hutchins did that's recorded that you also may like to look at. And now we'll transition forward to talking about debugging and testing for mobile. So this is a very important thing that you're going to be dealing with if you're targeting mobile. Not everybody can afford to buy every single type of mobile device. So there are these things called device labs that may exist in your community already that you can go in and rent time. You basically pay some money to test your application on all these different devices. Or you can, buy used devices off of eBay or whatever, or collect them in your office or whatever. But you need to test on a real physical device. Some of the different tools for remote debugging on Safari, it's called Web Inspector Remote. The Google Chrome has some information about how to turn on the USB debugging on the device. And if you don't use something like acetate or some other static site generator, you can always use live reload to inject JavaScript into the page, and then it'll cause that page reload across all the different devices and such. So there's where you enable the remote web inspector debugging. So you have to turn that on your iOS devices. And then on your Android devices, you'll also need to go under the developer tools, USB debugging, and turn that on so that you can do the remote web inspection. So that's what it looks like under iOS, and I'll show you this here in just a second. So I have another video, a screen recording that I did that shows, basically I have my devices attached and I have these maps set up, and so I'm inspecting the code that's actually on the device. I refreshed the browser, it's reloading, that breakpoint catches, and as you can see the screen has paused, and then you can inspect the variables and such inside of the application at that point. So if for whatever reason your app isn't working or whatever, maybe a click event's not working on a widget, this is the kind of thing that you're going to have to do. And also on the iOS device, opened up the inspector here, set the breakpoint, refreshed the app, and then that stopped at that point, and then you can do the inspection of the elements or the JavaScript at that point. You can also just directly type right into the console, which is basically what's on the device, and the navigator.user agent will report back to you what the browser actually is on that device. That information is critical to report if you are reporting a tech support incident or something, so we know what your device version is, what was the navigator user agent, which is the browser version, and what other kind of information you were doing or interacting with. So under when you have your device connected, there's a new setting in Chrome where you open up the developer tools and you click remote devices, and that'll actually show you which device is connected, and you can either type in the URL here and launch a new tab on the device, which is very handy, or you can just inspect what's currently running on that device. And this is what you saw earlier that we were looking at. And then with Safari, if you have it plugged in, you'll see the device that's on there. And then if you have Safari open on the device, it'll show what page is open in Safari. And then you can pick and start interacting with that, look at the page elements and such. And so these are skills that you must learn in order to be doing development on mobile devices, because it gets very difficult to diagnose. So get it to work in the desktop first, make sure you don't have errors in your code, and then move on to the mobile devices. So now I'll turn it over to Andy, and he'll move us forward.
4. Looks like we're good. Thanks, Lloyd. We're not going to talk too much about responsive frameworks for mobile. Just going to really skim the surface, lightly touch on them, and give you some ideas what is out there, because if we go to a browser and you look on the agenda, and if you're on the online agenda and you search for the word framework, there are all sorts of sessions. In fact, there's one going on right now, unfortunately, using frameworks by Renee, with Renee. He's presenting this one, and that's with the ArcGIS API for JavaScript. And there's a bunch of others. There's an Angular 2 session tomorrow, for example. Just giving you an idea that there's a lot of sessions related to working with frameworks and the JavaScript API. Why would you want to use a responsive framework, especially for mobile? The key reason is productivity. There are a ton of enhancements in a lot of these frameworks that'll save you not only frustration in terms of trying to make things work well, but also they're pre-built specifically for mobile devices. So in the majority of cases, you shouldn't find yourself tweaking scroll bars and tables and dealing with positioning. In theory, these responsive frameworks should do a lot of that for you. They also come with boilerplate layouts that you can take advantage of, so you're not building mobile applications from scratch. It goes right back to productivity. It's a huge time saver. If you're building large apps, commercial apps, and you need scaffolding to build these apps out, you don't want to be building those from scratch if you really don't have to. And last but not least, underneath the hood of these frameworks is a JavaScript API. It's there somewhere. Sometimes you have to look at it. So just to give you an idea of some of the repos that are out there, and there's also community repos by people like you out there in the community that are publishing repos. These are at github.com/Esri. I've checkboxed which ones work with the JavaScript API version 3 versus JavaScript API version 4. Bootstrap map JS, that one has basically been retired at JavaScript API version 3. If you're going to be doing bootstrapping on the JavaScript API, you want to use calcite maps like Lloyd demonstrated. There's also a jQuery mobile map sample out there on github.com/Esri. That's specifically for the JavaScript API version 3. You don't need it at all in JavaScript API version 4. Angular Esri map, which is Angular 1. If any of you guys doing Angular 1 development? Few. Angular 1, that works with both JS API version 3 and our API version 4. And of course, calcite maps, which Lloyd was talking about, is primarily our API version 4. And last but not least, we have a Cordova PhoneGap app out there that works on both the versions of the API. There's quite a bit of stuff out there to at least get you started. And there's many more examples that we simply don't have time to cover. But just to mention a few, I've already talked about that we have a Cordova example on GitHub. A lot of people are also doing Ionic development. Again, these are all samples. I'll believe I have a slide for that, and I'll go into detail on a couple of those. For Cordova, we have a quick start application. This is quick start map PhoneGap, and primarily what I wanted to show you is that there's a bunch of sample applications in here to get you started. It also has a description of the life cycle that you want to use when you run the JavaScript API. It's actually pretty straightforward. Anybody in here doing Cordova hybrid development? Few? The key thing here is if you're getting started in this or having lifecycle issues is you want to wait for the device ready event. The device ready event tells you that Cordova is done loading, and then I recommend after that is when you would load the JavaScript API normally, just like you do. Now this is in complete contrast to how the JavaScript API works in some of these other frameworks that I'm going to show you. This pattern right here is by far the easiest, but if you abide by the life cycle of these frameworks, your life will be so much easier. This one's pretty straightforward. Some of the samples in here are, there's a basic map, 3.x API, basic map with a 4.x API. Some of the comments we get back is the long load times in Cordova. So there's a splash screen example in here, which is pretty cool. Also working with web maps and GPS. There's a number of different samples that you can tap into to play with to get an idea of how these applications work with the ArcGIS API for JavaScript within the Cordova framework. And when we say Cordova, we use Cordova and PhoneGap interchangeably. For those of you that aren't familiar with it, Cordova is an open source Apache project. PhoneGap, which is a fork of Cordova, is owned by Adobe. We also have a plugin for Cordova. This works only on Android. One of the key problems that we have is, see if I got a screenshot here. One of the key problems that we have is separating out for mobile applications the GPS from the network location. When your phone is hooked up to a cellular network and you're trying to get a coordinate, has anyone here ever noticed how the location bounces around? Well, this plugin, which works for Android, lets you separate out GPS from the network. And I can actually show this to you live. I'm running it on my machine. And I'm going to be so brave as to actually try and connect to it. There we go. So over here on the right, you can see that it is, this app, it's running on this phone right here. It's actively pulling in locations and getting satellite data and all sorts of other stuff. This is a native plugin, so it's not using anything related to the browser. It's talking directly to the Android location manager. And the interesting thing that I wanted to show you is not only are we getting GPS locations inside a building, which in itself amazes me, but we're also getting network locations. And in a regular application that doesn't separate these two, the location will actually bounce around. By using something like this plugin, you can separate those two and just focus on either network for indoor routing or location, or just GPS. And you can see how it's jumping around there a little bit. Pretty cool, right? It actually worked. Ionic, I know a few of you are using this. For those of you that aren't familiar with Ionic, Ionic is a highly optimized version of Angular that's built on Cordova. Cordova lets you take a regular JavaScript application that you built and it puts it in a native wrapper for iPhone or Android and a number of other devices. Again, this is about productivity. We have a number of community repos out here that show you how to work with Ionic 1. Jacob has published on his own website, Jacob works for Esri, an Ionic 1 sample. On my GitHub repo, I've published an Ionic 2 sample. So if you're doing development in Ionic 1, even though the current version is Ionic 2, so perhaps you have an existing application, this is a great place to get started. There's instructions on how to use this repo. And if you're using the latest and greatest version of Ionic 2, this is at my personal repo site. And the key thing is it's showing patterns on how to work within Angular. Now we're going to go into more details on this at the Angular 2 session tomorrow. But if you look through the TypeScript page on this, you'll get an idea that this is much different in terms of how you load the ArcGIS API for JavaScript within the Angular 2 world as compared to how you would do it normally in a regular web app or how you would do it in Cordova. It's completely different. So if you want more details on that, come and see us tomorrow at the Angular 2 session. I already showed you the advanced plugin for geolocation that works with Android only on Cordova. I've also published a repo called HTML5 Geolocation Tool that's out on the github.com/Esri site. This is on the Esri GitHub repo. There's two different applications in here. One, which is under index.html, lets you tweak and adjust the existing properties of the HTML5 Geolocation API. So you don't have to build your own application if you want to play with max age or timeout or high accuracy and those types of things. You can change these settings in this particular application, scroll back to the main screen, and they will take effect immediately. So it's a really easy way to test out the different properties of the Geolocation API. The second one is a field location template, and I have this running on my phone, and I'm going to be brave again and try and show this to you live. What the primary purpose of the field location template is, it does geolocation averaging, because the geolocation that's coming off your phone and some of these non-commercial external GPSs give you a tremendous number of locations, and your location actually drifts over a period of time. This is just a prototype example of how to get the geometric average of those point distributions. So as you can see in this screenshot, we have quite a distribution of points. Which one's the right one? This is calculating the geometric center of those lat longs. Pretty cool, right? So let's see if we can actually go grab this thing. And I'm just using the same pattern that Lloyd was using before. This is in Chrome. And I'm going to the developer tools, more tools, remote devices. And in theory, my device is going to be here somewhere. And if it's not, I have prepared for this moment by having another browser open that should have the device connected. Ha, I planned ahead this time. And I should be able to, oh, is it going to work? I think I have to close that other browser. I know I can do it. There it is. Field location template. I think I can't have two of these open at the same time. Oh, it's not going to do it. I tried. At least I have a screenshot. But I can also show you that even though you can't see it, it looks just like the screenshot. It's running live on my phone right now. I'm running Android Studio, and I just wanted to show you that even inside this building, every time this log scrolls, it's pulling in another location from the network. So if we were to stop this and just take a quick look, you can see even inside this building, we're getting lat longs, we're getting at the median of the accuracy. We're not getting any speed information. We're not getting any distance information. But you can also see some other information in here that you can get from this template if you need to improve the locations you're getting for field data. Field data collection is we're getting standard deviation for accuracy in the lat longs. There's a lot of other information in here related to doing a better job on getting accurate locations. So the next section I wanted to talk to you, and perhaps this is the most important one from a mobile device perspective, is talking about performance and shifting gears mentally from the device that we build these applications on is usually much more powerful than a smartphone or a laptop. Your smartphone or your tablet, they have significantly less memory. This phone right here has 3 gigs of RAM. This laptop has 16 gigs of RAM. This has significantly more CPU than this device. So the application performance is never going to be the same on these devices. And there's many other factors that affects the performance. So what we like to recommend is just focus on small tweaks in your application that are going to get you the biggest gains. There's a saying amongst mobile application developers is you can really go down a rabbit hole focusing on that tiniest detail, trying to get the tiniest little bit of performance gain. But if you can, really try and resist that. I know it can be hard. And one of the most obvious ways to know that something isn't working right in a mobile application, and I bet it's happened to everybody in this room, is when the frame rate, the way that the application is being displayed is interrupted by something going on in the application, and it starts jerking when you want it to do something. And you all have probably seen this. And it can result in your application being locked up temporarily. Maybe you're scrolling a list and you're scrolling it and you notice that it locks up and your finger goes past it and you have to come back and try and scroll it again. Slow app responses. Under the worst scenarios, you can get browser warning messages that says, this application is not performing correctly. Do you want to close it? Or just the browser or the application just completely crashes. And web browsers are surprisingly fragile. And actually, this metric right here, jank, jerkiness, whatever you want to call it, this metric is from Google. This isn't something that we came up with. That any interruption greater than 16 milliseconds in the frame rate that's being displayed to the end user is going to cause some sort of interruption. And the reason why we want you to be aware of these things, and this is just raising awareness, is it decreases the usability. If every time someone goes to pinch and zoom the map, it's locking up, they're not going to be very satisfied with it. They're going to have decreased productivity. Usually they're going to be really frustrated if this keeps happening. If it's a public-facing app, like a travel app or something like that, then you're going to decrease the number of users that are coming back to this. So common causes of jank or jerkiness in the application, slower internet. You don't have any control over this, right? But you need to be aware of it. Downloading large files. That can completely lock up the user interface, not only on a laptop, but especially on a phone. Heavy processing on the main thread. If you download this large file and you have to loop through it, you're going to lock up that app. If you're doing a lot of DOM layout changes in your CSS or your application, the user isn't going to be very happy. So some of the things we do to help correct this or redirect people's attention, there's many different theories on this. This is just a general suggestion for things to keep in mind. We use spinner bars, progress bars, we use loading screens, just to let people know that, hey, this is a long operation. Don't panic, it's going to be okay. You can also use splash screens or login screens. Here's a demo of a splash screen. This is in a regular browser on my laptop, but you can use this same one in Cordova. This is included in a sample app in the PhoneGap Quick Start app repo. But you can see here that as the tiles load, and it's much more apparent in Cordova because that has a longer load time, it's kind of nice to not let them look at a gray screen. You want to give them something pleasant to look at. The Chrome profiler tools are awesome. This is just one example. You can really dig down into the meat of everything that's going on in your application and what's taking up the most time. And I just picked this particular example as parsing a large feature, and I'm going to show you another example of this where it's taking up almost 13% of the total load time for this application. So it's a pretty significant hit. You can find those things using the Chrome profiler tools. So what we look for inside the application is using console time. This is different than console log. You can do console time, which is to start this counter, and console time end to end this counter. And it works in 1/1000th of a millisecond. So you can start console time before a long-running task and run time end after the task to measure how long it's going to take. This is a huge tool that we use to measure long-running applications. You can also outsource stuff to web workers, get heavy working applications off of the main thread. The primary culprit for this is large data sets, downloading big GeoJSON files, downloading large feature sets from a feature service. Because what the user sees is not just the download time. There's three things that the user has to sit through. They have to sit through downloading that file, the time to parse that file, and then the time to render that file. So there is three things that you should be aware of in terms of working with large data sets. So typically what we do is we outsource these to web workers. There is a sample on GitHub. It's called the earthquake heat map. Oh, I'm sorry, it's on my personal website, earthquake heat map layer at andygup.github.io. So what I wanted to do was run this sample. It's pulling about a 780K GeoJSON file of earthquakes over the web. Using no web workers, it took about 2 seconds for this to parse that file. So let's go ahead and add one web worker to that. And one web worker dropped our parsing time down to 514 milliseconds. So last but not least, let's do the parsing with 2 web workers. So we went all the way from 2 seconds, 2 whole seconds that the user had to wait for just the parsing operation with no web workers to 390 milliseconds. So that's about a 6 to 7x performance improvement by outsourcing stuff using web workers. If you want to go ahead and look at that repo, it's on my personal site, which is github.com/ANDYGUP. And this slide was actually supposed to be hidden. So to wrap this up, We just want to let you know and remind you that mobile is not desktop. We showed you many different considerations from designing apps or apps and templates that are pre-designed just for mobile. We also looked at remote debugging. One thing I do want to emphasize is if you want to debug iOS, you're going to need a Mac. You don't necessarily have to buy a brand new Mac, but in order to debug an iPhone or an iPad, what I recommend to a lot of people, especially in larger cities, is you can buy Macs used. There's refurb places, you can get them on the internet. But if you're debugging iOS, you will need a Mac. You can debug Android on either Mac or Windows. And last but not least, there's special performance considerations for mobile. Hopefully you've seen or at least given you the idea that there's a very fine line between what causes an inconvenience for a user and how you treat something within the code that you're writing. One of the ways to improve performance is using web workers, and I just gave you a quick demonstration of that. And so we also want to encourage you to give us feedback. You can download the feedback app if you haven't already from Google Play or the Apple App Store. And with that, we'll open it up for questions. Yes?
Can you show the slides for the web worker, if you allow?
You're welcome. Other questions? Yep.
So is there any true science to what GPS is doing? Like, why is it working, for example? Why is it horribly inaccurate sometimes? I mean, I go from one device to another, and you just never know what's going to happen. And I don't have any good answers for the clients either, because I'm like, well.
The question was, why is the GPS in smartphones?
Is there a source that tells you why it works? Okay, why doesn't a satellite GPS work in a room when it can't see the satellite? Why, when I go out in the field, am I going to be so far off with the phone? And another day, I use a different device and I'm spot on. Not getting consistent results with these devices on location.
So the question is, and I'm just repeating it since the session's being recorded, about consistency of results in GPS. That's a longer conversation. Just so it gets recorded, I just got done doing an advanced GPS session for web apps, and that video will be available as well as the slide sets. And if you can come up and talk to me afterwards, I can give you a better explanation than in the 2 or 3 minutes that we have.
Yeah, I'm just wondering if other people are having the same problem.
They are, and if you come up, we can talk about it in detail. Be happy to. Anybody else? Yes?
What would be the main reasons why I would choose to develop with JavaScript for mobile as opposed to any of the runtimes?
The question was, why would I choose JavaScript over any of the runtimes? And the question comes down to requirements and use cases and skill sets, those 3 things. If your requirements call for capabilities that aren't available through JavaScript, that's a given. If your use cases call for capabilities that don't exist in JavaScript, then the same thing would apply. And also we see a lot of questions related to existing skill sets and budgets. If you are a JavaScript shop and those are the skills that you have, can you acquire the skills to meet your requirements for Android or iOS or both? And do you have the budget to do that type of work if you're not geared towards doing native development? And we can talk about it more afterwards, but that's the short answer is requirements, use cases, and skill sets.
There's actually a really good article on the developer site. So if you go to developers.arcgis.com, and then from that main landing page under like choose the API, if you choose the runtime SDKs, this link is right in the middle of that page. So I can just back up and show you here. So this is the main developers page, APIs and SDKs. If you go to runtime SDKs, and then you scroll down, and it says choosing the right Esri API. This originally was a blog article that I wrote or helped write, and this goes through and talks about the stuff that like Andy was talking about, like requirements, native versus web strategies, comparison points, what are the different requirements as far as like how do you deploy the thing? Do you need offline access? Just sort of a slew of this stuff that you can sit down and start a whiteboard discussion with your development team or the parties that are involved that are going to be owners or users of your application, and will help you figure out, will this work this way or not? It does get a little fuzzy, especially as the technologies get stronger. But a lot of it comes down to, requirements of the application, and then also resources and development. Not everyone is a native web or a native runtime, Java, Objective-C, Swift, Xamarin, C#, all that kind of stuff. They just don't have that skill set. But a lot of shops do have web developers in-house. So it's kind of a convoluted answer.
And that was a good point, just to re-emphasize offline. If you have a need for fully supported offline with robust capabilities, then you're going to have to go with one of the runtimes as an example of a requirement.
If you want to be confused further, tomorrow we do have a session that's integrating, talks about a research project that went on for a customer of using the JavaScript API with the runtime SDKs with Cordova to generate an offline solution that used both technologies.
Well, I guess at this point, yeah, we can take one more question, then we'll wrap it up.
The difference, I noticed that I get a lot more jank from Safari. Is that something other people?
The question was, you get a lot more jank on Safari?
Yeah.
Could be so many different things.
Is that a Safari thing, or is it not common?
It's been my experience that generally if you're on a Mac or on iOS, the best performance is the native Safari application. I haven't experienced that personally. You can download other browsers for the platforms and people can use them. But for the most part, it'll launch Safari by default with that. But I don't know. It's interesting. You could do like some profiling and testing and try and figure out, where the bottleneck is, or if it's your app, or if it's something else. It's very difficult to pinpoint whenever issues start to occur. It's like that you really have to kind of tear the thing apart and start figuring out, where like separate out the different pieces of the application and almost kind of test some of it individually in order to really be able to tell.
I agree with that. It's forensics at some point. You cross the line from just debugging into forensics and really using, you want to go ahead and switch the screen, like what I was showing with the Chrome profiler tools. There's other tools within Chrome that also let you look at user interface, loading times, and things like that. And that's really where you're getting into the detailed fine-grained research of where the problem is occurring, and that's really what it takes in some cases to figure out what the deal is. No, it's not an exact answer. It's more of an art than a science at some point. Really figure it out. Well, we've reached our time limit for the session, but we'll be up here for a little bit longer. I know there was a few more questions. We want to thank everybody for hanging with us and hope you have a good day tomorrow as well. Thank you.